Welcome to Ask and Learn.
So to solve for A, you are going to use the formula for capacitance as A epsilon naught K divided by D. Area is 21 by 14 centimeters square. So converting them to meters will be 0.21 and 0.14. This is value of epsilon naught and this is K divided by the distance, which is given in terms of millimeters, so we must multiply it by 10 power negative 3, and if you calculate it you will get the value 32 nanofarad, means 32 times 10 power negative 9 farad. Now let's solve for B. We are supposed to find the charge, maximum charge we can store, which is C times the potential difference, but we are not given the V. V in terms of electric field is E times D. So since we know E and D, we can use this formula. We know this is 32 nanofarad, so 10 power negative 9. Electric field is 15 times 10 power 6, which is maximum electric field or dielectric due to dielectric strength, and the D, which is again 0.03 times 10 power negative 3. If you calculate this, you will get 14 microcoulomb. Micro means 10 power negative 6. Now let's solve for C. The C asks, how will you overlay the sheet of paper and aluminium for the parallel combination? So let's say this is your aluminium and this is your paper. This is your aluminium again, and you want 100 such capacitors. So you can have one more paper down here. So this is aluminium, again aluminium. This is paper. This is paper, and again aluminium alternatively. So you will need 101 aluminium sheets. So this will be aluminium sheet and 100 paper sheets. So you will need 101 aluminiums and 100 paper sheets. How will you connect it? It's simple. You will connect this plate, then this plate, which is again aluminium, and alternatively, so this plate here will be connected to negative terminal, let's say, then this plate will be connected to positive terminal, so making this capacitor here a small capacitor. Again, to make capacitor here, since this plate is negative, this plate should be positive, so this is connected here to positive terminal. Similarly, since this is positive, this must be negative, so this is connected to negative terminal. And so we are making, so this is paper, so let me make paper a bit thick to make it different. So let me draw with the colors given to me. I'll draw aluminium with the black, aluminium, aluminium, aluminium. I can draw many aluminium foils in between, so let me draw them. And I'll draw paper sheet with the red color. So this is how you will make 100 capacitors. Now to make them, you need to connect all the capacitors, all the plates to proper sign of charge. So let me draw few more lines so that it's much clear. Now I'll use the green color to denote positively charged plates. So if you charge this positive, you must charge this one negative, and again you must charge this one positive. So this is connected to same terminal of a battery. So similarly, this one will be positive, this one will be positive. So alternative plates are positive and alternative plates are negative, which are this, then this. So you have 101 such plates, so that now you can have one capacitor here, one capacitor here, one capacitor here, and all of them are parallelly connected, making them, you can simply add the capacitance. So final capacitance will be 100 C naught. Since we are asked to find thickness, we are using 101 aluminium sheets and 100 paper sheets. So we know that 101 aluminium sheets have thickness of 0.04 millimeter. So we must multiply by 10 power negative 3, and paper has thickness of 0.03, 10 power negative 3 again. So let me perform this calculation on my calculator. So this is 4.04 plus 3 times 10 power negative 3, which is equal to 7.04 millimeter. Now the last part of a question is D, which is maximum voltage that you can apply to this 100 C0 capacitor without breakdown, since voltage is electric field times D. And as you saw here, these plates are separated by this paper with a dielectric constant of 15 times 10 power 6. You can't have electric field which exceeds that limit. So electric field is still constant. So the same value, not constant. And the thickness, which is paper's thickness, is 0.03. So you'll have and times 10 power negative 3, which I should not forget. You'll have 0.45 times 10 power 3 volt. This is 450 volt. So this is no matter how many plates you add up and make capacitor, this thickness is still the same, and that makes maximum potential constant. Thank you.